Imagine a small SaaS team looking to leverage AI to streamline their workflow. They turn to our Multi-Tenant AI SaaS product, which empowers them to authenticate, run AI workflows, save results, and manage billing-ready workspaces with ease. Let's consider a realistic request. A user wants to analyze customer feedback from various sources, identify trends, and generate a report with actionable insights. Our product handles this request seamlessly. The user interacts with the product through a modern, customizable UI, which serves as the input boundary. They upload their customer feedback data, select the desired AI workflow, and configure the output settings. The product then processes the request, and the user receives a comprehensive report with visualizations and recommendations. This output boundary is where the user receives the value from our product. Behind the scenes, our product's architecture is designed to handle such requests efficiently. The UI repository provides the front-end framework, allowing us to build a responsive and intuitive interface for our users. When a user initiates an AI workflow, the LangChain repository takes over, leveraging its capabilities as a large language model framework to process the customer feedback data. This is where the magic happens and the AI workflow is executed. The CopilotKit repository plays a crucial role in enabling our product to build agent-native applications, which can power various surfaces, from web apps to mobile apps. This allows our product to provide a unified experience across different platforms. Meanwhile, the PipesHub AI repository handles the backend data responsibilities, providing explainable and extensible enterprise search, knowledge graph retrieval, and permission-aware access controls. This ensures that our product can connect enterprise knowledge across the organization while preserving access permissions. Lastly, the container repository ensures that our product is deployable and manageable from a DevOps perspective, using a tool optimized for Apple Silicon and written in Swift. This enables our product to run Linux containers as lightweight virtual machines on Macs, making it easy to develop, test, and deploy our AI SaaS product. With these repositories working together, our product provides a powerful and streamlined experience for small SaaS teams looking to harness the power of AI. As a small SaaS team uses our Multi-Tenant AI SaaS, a request is initiated when a user authenticates and creates a new workspace. This request is handled by the UI repository, which provides a modern and customizable front-end for the application. The UI repository uses the AGUI protocol to communicate with the CopilotKit repository, which is responsible for managing agents and their interactions with the user interface. When the user creates a new workspace, the UI repository sends a request to the CopilotKit repository to create a new agent instance. The CopilotKit repository then creates a new agent and returns its identifier to the UI repository. The UI repository stores this identifier in the user's session data, which is persisted in a database managed by the PipesHub AI repository. The PipesHub AI repository provides a knowledge graph that stores information about the user's workspaces, agents, and other relevant data. When the user runs an AI workflow, the PipesHub AI repository is responsible for executing the workflow and storing the results in the knowledge graph. The PipesHub AI repository also provides a search interface that allows users to query the knowledge graph and retrieve relevant information. As the user interacts with the application, the data flow is managed by the LangChain repository, which provides a framework for building AI-powered applications. The LangChain repository uses the container repository to manage the execution of AI workflows and store the results in the knowledge graph. The container repository provides a lightweight and efficient way to execute containers on the user's machine, which is optimized for Apple Silicon. When the user saves the results of an AI workflow, the LangChain repository stores the results in the knowledge graph, which is managed by the PipesHub AI repository. The PipesHub AI repository then updates the user's workspace data to reflect the new results, which are stored in the database. The UI repository is notified of the update and retrieves the new data from the PipesHub AI repository, which it then displays to the user. Throughout this process, each repository hands work to the next by using well-defined API contracts and events. For example, the UI repository uses the CopilotKit API to create a new agent instance, and the CopilotKit repository uses the LangChain API to execute AI workflows. The PipesHub AI repository uses the container API to execute containers and store the results in the knowledge graph. By using these API contracts and events, each repository is able to focus on its specific responsibilities and work together to provide a seamless user experience. To build a practical MVP, we start by setting up the UI repository as the front end, using its modern components to create a user interface for our multi-tenant AI SaaS. Next, we integrate the LangChain repository as our LLM framework, allowing us to chain together components and third-party integrations for AI application development. We then use the CopilotKit repository to build agent-native applications, enabling generative UI, shared state, and human-in-the-loop workflows. This will allow our users to interact with the AI models in a more intuitive way. After that, we set up the PipesHub AI repository as our backend data layer, providing explainable and extensible enterprise search, knowledge graph retrieval, and permission-aware search. For local development, we can use the container repository to create and run Linux containers as lightweight virtual machines on our Mac. This will allow us to test and develop our application in a self-contained environment. We can write tests for each component, such as if user clicks button, then trigger AI workflow, or if AI workflow completes, then save results to database. To handle background jobs, we can use a job queue like run AI workflow when user submits task or send notification when workflow completes. We can also use the container repository to run these background jobs in a separate container, ensuring that they don't interfere with the main application. For production deployment, we can use a cloud provider like AWS or Google Cloud to host our containers. We can set up a load balancer to distribute traffic across multiple containers, and use a database service like PostgreSQL or MySQL to store our data. We can also use a monitoring service like Prometheus or Grafana to keep track of our application's performance and metrics. In terms of pseudocode, our interface might look something like user submits task, trigger workflow, save results, send notification. Or, if workflow fails, retrieve workflow, send error notification. This will allow us to create a robust and reliable application that can handle a variety of user inputs and workflows. By following this build order and using these repositories, we can create a powerful and scalable multi-tenant AI SaaS that meets the needs of our users. The backend ties together with PipesHub AI, where you'll start by setting up its self-hosted context layer. Clone the repo, then run Docker Compose up to spin up the default stack, assuming you've got Docker installed. Environment variables like LLM provider API KE and database URL need setting in env for authentication and persistence. It enforces permission-aware search out of the box, so you'll map your organization's access controls via the admin UI or YAML config files. Note that while it's SOC 2 compliant, you're responsible for infrastructure security if self-hosting. For the agent layer, CopilotKit streamlines full-stack deployment. Install via npm install at CopilotKit SDK, then initialize a project with Copilot in it, which sets up a default agent with streaming chat UI and tool integration. Configure your LLM key via Copilot API KE in env. To enable persistent threads, add persistent storage1 to your config, which uses a built-in SQLite database by default, but recommends PostgreSQL for production. Deployment involves building the front-end, npm run build, and hosting static files alongside your backend. LangChain handles workflow orchestration. Install with pip install LangChain, then structure your AI chains using Python or JS. Set environment variables like OpenAI API KE and Pincone ID for LLM and vector store integration. Run chains via Python chain.py or embed them into FastAPI endpoints. For multi-tenancy, you'll need to implement workspace IDs in your chain inputs and database schemas manually, as LangChain itself doesn't enforce this out of the box. The container tool from Apple simplifies local development for Mac users. Install the latest release from GitHub, then build and run images using container build tmyapp and container run myapp. Note it's only compatible with Apple Silicon Macs on macOS 26 Plus, so cross-platform teams will need alternatives for non-Mac setups. To start today, clone Chat.NUI, run npm install, and explore the component demos with npm start. Then integrate a LangChain workflow by adding an API route in your backend and connecting it to a CopilotKit agent. How would you approach rate-limiting LLM calls across multiple user workspaces while keeping costs predictable?